Hey everybody, my name is Lindsay. I'll be sharing with you stereochemistry, specifically naming isomers with CIP to assign the R or the S prefix. So isomers, as a refresher, are compounds with identical molecular formulas but different arrangement of atoms. Over here on your left, you can see that the hydrogen is on the wedge, whereas the fluorine is on the dash. And on this side over here, they're reversed. The fluorine is on the wedge and the hydrogen is on the dash. Both of these are bromochlorofluoromethane. However, the spatial arrangement of the atoms differ. So if you were to just say this is bromochlorofluoromethane, there could be different ways that the atoms are and the elements are presented. Therefore, the R and S prefixes will make it very specific so that there's no confusion about what you're referring to. In order to identify R&S nomenclature, you need to make sure you have a chiral center. So you'll see that the chiral center is a carbon molecule with 4 different groups attached. That would be the middle carbon here on the molecule. So CIP stands for Kohn-Ingold Prelog rules, and you have a couple of different steps in order to assign things accurately. So the first thing you want to do is assign priorities to the substituents based on atomic number. Then you're going to orient the molecule so that the 4th priority is pointing away from you. If you had your model kit, that would make a little more sense since you'll probably be doing it on paper most of the time. It's just the last priority and it's always the default one that's away from you. And then you'll trace the path of the priorities 1 through 4. Priority number 4 being on a dash, if your tracing goes in a clockwise circle, it's going to be an R. If it goes counterclockwise, you are looking at an S. Now, if priority number 4 is on a wedge, those just reverse. That means if it's going clockwise, you're looking at an S, and counterclockwise, you're looking at an R. So prioritizing according to the atomic number is based off of the periodic table. So, for instance, hydrogen is always the 4th priority. It is the lowest atomic number. So with it being number 1, you can just default it to the 4th position. Another example would be carbon. Its atomic number is 6. And then just a third one to really drive the point home is bromine with the atomic number 35. So looking back at our friend here, you have hydrogen, fluorine, chlorine, and bromine. I've placed them in order with ascending atomic number. Looking at the one on the right over here, bromine is going to take the 1st priority because it's the highest atomic number. Chlorine will take the 2nd, fluorine will take the 3rd, and hydrogen has the 4th. Now, fluorine is on a wedge, so this would be, in my opinion, the easiest case when it comes to naming based on R and S prefix. You're just going to trace around. We're going clockwise in this example. So this would be an R. Now, the guy over here on the left, we have the same order. R, bromochlorofluoromethane. We have the same priority over here. It's still bromine is 1, chlorine is 2, fluorine is 3, and hydrogen is 4. But fluorine is on the dash. So even though we're still going clockwise, this dash makes a difference in the identification, and we are going to call this one an S, which would make it S bromochlorofluoromethane. Now, kind of double dipping into someone else's topic, the chiral center for this one is a 1, so you're going to have just the 2 options for your isomers. So example number 2, we're looking at priority number 4 on a dash. Again, for me specifically, this is the easiest way, the easiest example of an identification. Again, you want to start with assigning your priorities. So oxygen is really what we're looking at here. It is a higher atomic number than hydrogen. We are looking at the ethyl group as priority number 2, the methyl group as priority number 3, and then the hydrogen, of course, is priority number 4. The movement is clockwise. Oh my goodness, which would make it an R. And we're looking at R2-butanol. Now, the third example is a priority number 4 on a wedge. So if you'll remember, the priority number 4 on a wedge means we just flip our clockwise versus counterclockwise R and S's. So bromine takes priority number 1. We have the ethyl group again with priority number 2 and the methyl group with 3. Hydrogen is 4, but it is on the wedge. Still moving clockwise, but it gets the S determination because of the wedge. So this is S2-bromobutane. Now the ethyl versus the methyl determination is just because of the number of carbons. There's an example later on using a ring where I'll go into this a little bit deeper. But for me, I always just try and remember ethyl comes first alphabetically. That's not chemistry related at all, I'm sure, but I identify an ethyl group, and if I see it over a methyl group, it gets priority number 2. So just a trick of the trade for me, but probably doesn't actually have any organic chemistry foundations. So you might find a molecule that has multiple chiral centers. I apologize for my little baby hydrogen on a wedge here. He was chopped off, so I had to add him later. We are going to start with just determining your chiral centers. You'll see both of these centers are 4 different substituents, so they are both chiral centers. For this one down here, I went with bromine first because alphabetically it's first. That one gets the number 1 priority due to the atomic number. The rest of the molecule gets the number 2 priority just because of the atomic numbers over on this side. Over here, the ethyl group gets the 3rd priority, and then the hydrogen on the wedge gets the 4th. So since hydrogen is on the wedge, even though we're moving clockwise, this is an S, just like the one before. The second chiral center with chlorine. Chlorine gets the 1st priority. The rest of the molecule gets the 2nd priority. The methyl group gets the 3rd priority, and the hydrogen on the dash gets the 4th. This is also moving clockwise. Also, ignore the 4 when you're trying to figure out what clockwise is. That threw me off for a bit. Just pretend like it doesn't exist, because if you can see here, 1, 2, 3 goes clockwise, but if you're trying to factor in the 4, that can trip you up, or it tripped me up in the past. So since this one is moving clockwise and the chlorine is on a wedge, we are looking at an R. Then you would just name as normal. So the determination of your chiral centers goes just in numerical order. So we have 2R, 3S, but then you follow regular IUPAC rules for the rest of it. So this is 2R, 3S, 3 bromo, 2 chloropentane due to alphabetization. Finally, for the 5th example here, we can look at some cyclic compounds. So I did want to point out that this does have a chiral center. These are not the same molecule on either side because of the double bond here with the cyclohexene ring. When you are trying to determine which side of the, which substituent group is the one that is going to take priority number, the 1st priority, or, the heavier priority, you really have to compare down the ring until you find a difference. So these 2 carbons here are the same, We have another same carbon, and we finally get down to this one down here that's attached to the double bond. This one is different. So because of that extra carbon, this priority over here is number 1. Number 2 on this side, the methyl group gets number 3, and then the hydrogen on the dash gets number 4. Again, we're moving in a clockwise rotation, which means that this is an R. So we're looking at R for methyl cyclohexene. And I'm not going to go over naming rules, but just remember it's an ene because of the double bond. So that was a quick review on naming isomers with CIP for R and S prefixes. This was all in Module 2, just as a kind of placemat for where you can go back to reference if I was confusing or if you need any additional notes. I referenced Masters of Organic Chemistry and several other YouTube videos to kind of drive the point home, but there is a lot of practice problems you can refresh yourself on if you did not get to them during Module 2.